Okay, Algebra 2, lesson 1.7 is called Representing More Sequences. All right, so our learning goal today is a little different. It's kind of a review lesson, but our goal here is I can ask questions to get the information needed to represent sequences in different ways. So basically, we're going to be given some questions, but they're not going to give us the info. So we have to ask the proper questions in order to solve the problem. But the information is not going to be presented to us. We're going to have to pull the information from your partner. All right, our warm up. Which one doesn't belong? Go ahead, pause the video and take a look at these and try to come up with a reason for one or two of them that does not belong, and make sure you have a good justification. All right, so as I take a look at this, if I look at A is the only one that's an arithmetic sequence. How do I know it's arithmetic? Well, when you look here at this -5, that means I'm taking this. Remember, f of n is here. This is f of n minus 1. That means f of n minus 1 is the previous term before the nth term. Okay, so when I put the -5 there, that's the only one that's subtracting or adding a number there to the previous term. So this would be the only arithmetic sequence. Okay. Um, when I go to the second one, when I go to B, a good reason for B would be it's the only one that keeps getting closer and closer to 0. So when you look here, you got the first term is 6. Okay. So actually, let's go back to this one. This one's 6, and then -5 is 1, and then -5, and then -5. It's like that. This one here is 6. It's times 1/2. You take the previous term times 1/2, times 1/2, times 1/2. And you notice that they end up getting closer and closer to 0. They don't actually become negative because you just keep timesing it by 1/2. It's going to get closer and closer to 0. So I'm going to say only sequence that approaches 0. Okay, when I look at this one here, when I go to the third one, this is the only one that starts with the 0 term. All the other ones, if you look here, they start with the first term. Okay, f of 1 equals 6 for all the other ones. This time it's f of 0 equals 6. So a little weird there. So I'm going to say only sequence that starts with term 0. Okay, a little weird. This is obviously geometric because you're taking the previous term times 10. So this would be like 6, 60, 600, 6,000, etc. Okay. And then D, this is kind of weird. It's not arithmetic or geometric. We add n squared there. Okay, so the first term is 6. Okay, and that's term 1. So then term 2, you're going to add n squared. So you're really adding 2 squared because this is term 1, term 2. So it's going to be 6 plus 2 squared is 6 plus 4. Term 3 would be, it's like I'm adding 9, so it'd be 19. Term 4 would be like I'm adding 16, so it'd be 35, dot, dot, dot. So it looks something like that. But this is the only sequence that is not arithmetic or geometric. Okay, you might have come up with some other answers for all of these, but that's one for each one of those. Okay. All right. So what we're going to do now is called an info gap, and one of you're going to have a partner for this. If you're watching this video, you're not going to have a partner. So I'm going to kind of simulate having a partner. And one of the persons is going to have a problem card, and the other person is going to have the data card. So, the person with the problem card doesn't know the info. They have to ask the right questions, and the data card person is going to look at it and give them the info if they have it, or if they have the info that they're asking for. So, problem card one: represent the first 5 terms of the sequence F by creating a table and sketching a graph. Okay, so I have no info there. So I'm going to ask the person with the card here. I'm going to say, "Do you have the first 5 terms?" And they're going to say, "No, I don't." Okay, and then I'm going to say, "All right, maybe do you have the first term?" And the person with the data card is going to say, "Yes, I do have the first term. The first term is 16." So that's awesome. There's my first term. And then I might say, "Do you have is it arithmetic or geometric?" And they're going to say, "I don't know." And they might say, or I might ask them, "Do you have a rule? Do you have a function rule?" And they're going to say, "Yes, I do. Here's the rule." So to find the nth term, you take the previous term and divide it by 2. So dividing by 2 is kind of the same as timesing by 1/2. So if this was the first term, to find the next term, you divide 16 by 2, divide 8 by 2, divide 4 by 2, divide 2 by 2. There's the first 5 terms. Now, it doesn't say to make it a list. They say make it a table. So if I said n and then f of n, kind of like that. First term is 16. Second term is 8. Third term's 4. Fourth term's 2. Fifth term's 1. So there's my table. Check. Now I have to sketch a graph. So let's do this here. I'm going to just do a very rough graph here. And I always like to label my axes. So this is going to be term number. Okay. And then this is going to be the value, I guess. So I got to go from 1 to 16. So maybe if I go by 2s, 2, 4, 6, 8, 10, 12, 14, 16. And then I can extend this a little bit. Whoops. So 2, 4, 6, 8, 10, 12, 14, 16. And let's see here. Term 1 is at 16. Term 2 is at 8. Term 3 is at 4. Term 4 is at 2. And term 5 is at 1. All right, and that's how you get this curved shape, because we know it's a geometric sequence, okay? So there we go. So the next one, what is the 5th term of sequence K? Represent the first 5 terms of sequence K by sketching a graph. Okay, well, I'm going to say, do you know the first term of this sequence? That's probably my first thing that I'm going to ask. Do you know the first term? And they're going to say, yes, I do. I do know the first term. It's 16. So that's helpful. All right. Do I know the second term? And they're going to say no. I'm going to say, okay. Do you have a way to get the second term? And they're going to say, yes, I have a function. I'm going to say, oh, cool. Can you tell me what the function is? And they're going to reveal that to find the nth term, you take the term before the nth term and you subtract n. Okay, so this is, let's maybe put in, instead of doing a list, let's maybe make a table. So let's write it here. Let's go n and then k of n. So the first term was 16. We need the second term, third term, fourth term, fifth term. So to find the second term, so to find k of 2, I take the previous term, which was 16, and I'm going to subtract n. So n in this case is 2. So 16 minus 2 is 14. If I wanted to find the third term, I take the previous term, which was 14, and I subtract n. So n would be 3 there for that term. So 14 minus 3 is 11. If I want to find the fourth term, I take the previous term, which was 11, and I subtract n, which would be 4, so that would give me 7. And if I want to find the fifth term, I take the previous term, that's the k of n minus 1, and I subtract n, so I get that. Okay, so there is my table. I guess it didn't say to make a table, but now we have to make a graph. So let's go ahead and let's make a graph here. So here's term number. So I'm going to go 1, 2, 3, 4, 5. And term 1 starts out at 16. So I'm way up here. 2, 4, 6, 8, 10, 12, 16. I'll just skip everyone to make it a little bit easier. So term 1's up here at 16. Term 2 is at 14. Term 3 is at 11. So that's going to be kind of right in between there. 4 is at 7. And term 5 is at 2. All right, so there you go. Not really a line, not really a growth or decay function, kind of like a weird shape because it's not geometric and it's not arithmetic. So it's not going to be a perfect line, and it's not going to be one of those like growth shapes that we've had before. So it's neither a line nor growth, okay? All right. All right, next one, problem card 3. Represent the first 5 terms of sequence Q by making a table. Write a recursive definition. Okay, so let's make a table here. So n, Q of n. All right, so if they're asking me to write the recursive definition, I'm going to say they probably don't have that info. So I'm going to say, okay, do you have the first term? And they're going to say yes. And they have to, this person is going to actually have to take a look at the first term from the graph. So term 1 is right here. The first term is 16. Okay, and then I'm going to say, oh, do you have the second term? And this person with the data card is going to have to look at term 2 right here. Say, okay, term 2 is going to be 13. And then I say, what's the third term? And they're going to look up here and say, okay, that's 6. Fourth term is 1. And the fifth term is -4. Oh, you know what? I actually read that wrong. The second term is not 13, it's 11. Whoops. That was one less than 12. So there we go. All right, so as you look at this, you can kind of tell that it's -5 every time. So that makes me think that it's arithmetic. Okay, so there's my table. Here's my table, circle that. So arithmetic, so if I want to find the nth term, well, first let's say what the first term is. A1 is 16. If I want to find the nth term, I have to take the previous term. Oh, I'm using A instead of Q. It's Q, sorry. It's Q of n, Q of 1, Q of n. So if I want to find the nth term, you take the term before it, so it's the Q of n minus 1, and I just minus 5. And then we have to say we're taking n is greater than or equal to 2 because we start with the first term. and we're going to count up. So n is greater than 2. We're only going up. We're not going to go backwards. Okay, we're not going to have the negative 10th term. That doesn't really make sense. We start counting at 1. So that would be my answer there to that question. All right, so that's part 2. All right, so a little synthesis here. So here's my sequence J, 2, 8, 32, 128. So clearly it's geometric, and we're multiplying by 4. Okay, so we could use function notation. So j of 1 equals 2 right here. That means the first term equals 2. Then when I say j of 2 equals 8, the second term equals 8. Over here, j of 3 equals 32. That means the third term equals 32. And then same thing, j of 4, the fourth term equals 128. Okay, so that's a different way to write it. Same info. So if I want to put it into a table, I could say, n and j of n, first term, second term, third term, fourth term, and I would just say 2, 8, 32, 128. Same info, just presented differently. Here's our recursive definition. We need the first term. J of 1 is 2. That means the first term's 2. And then you take the previous term, to find the nth term, you take the previous term and times it by 4. Okay, so that tells me that's geometric. And then n greater than or equal to just tells us that we're going to count up from 1. And then they wrote these as ordered pairs here, 1, 2, 2, 8. Same info here as up here. They just wrote it as an ordered pair. And then, we're going to plot it on a graph here. So if I went 1, 2, 3, 4, I got to go all the way up to 128. So maybe I should count by 10. So I'll go 10, 20, 30, 40. I'm going to skip one, so I don't have to write as much. 50, 60, 70, 80. All right, first term is at 2, so it's like way down here. Second term is at 8, so just a little bit below 10. Third term's at 32, so it's right about there. And then the fourth term's way up here at 128. So there we go. And we got that nice little curve growth function because it's geometric. All right, so really a bunch of different ways there. We got function notation, we got a table, we got a recursive definition, and we now have a graph. So you should be able to interchange between all 4 of those methods of writing these sequences. All right, so here's a geometric sequence. So geometric, so that means I'm clearly timesing it by 1/2. It's not -6 because the keyword there is geometric. Write a recursive definition. Okay, so we need the first term. We use g. G of 1 equals 12. And then we say to find the nth term. What do we do to the previous term? Well, we are going to take the previous term and we're going to times it by 1/2. Okay, and then we also like to say n has to be greater than or equal to. That says that we're going to count up. All right, and then the last part, sketch a graph representing the first 5 terms of sequence G. You know what, let me go back here and copy this. I'll make it a little bit easier. So now I'm just going to plot those points there. Actually, I guess I need to generate the terms. So I'm going to go first term, second term, third term, fourth term, fifth term. This is n. This is g of n. So we said it was 12, 6. If we're times it by 1/2, that'll be 3, 1.5, and then 0.75. So from 1, 2, 3, 4, 5. I got to go all the way up to 12. So probably just count by ones. I'll skip every other one so I don't have to write as much. First term is at 12. Second term is at 6. Third term is at 3. Fourth term is 1.5. The fifth term is 0.75. So there we go. We get that decay shape, that curved shape getting smaller because we're multiplying by a number 1/2 here, which is less than 1. All right, so hope you enjoyed this lesson, and make sure you do your homework.